Alright, so we talked about law of sine and I kind of forced you guys, you to believe what is law of cosine. Hello Vidanshi.
Hello.
So, request to both the kids, be on screen so that we can discuss, argue and fight. If you guys are comfortable, I would suggest be on the screen, keep your videos on so that we can have more interactive discussion around the concepts. Yep. Is that okay? Or Vedansi is not ready today. I know I woke everybody up early in the morning. Okay, take your time. But everybody can hear me okay? Yes, good morning, beta. Arush, how about you, beta? We be on screen. I feel more included when I see you guys, okay? Otherwise, I struggle with myself, okay? Alright, so, in the last class, we started talking about law of sine, law of cosine. And Vedansi, a quick question for you, beta. Have you come across what is law of sine and law of cosine? Can you tell me what is law of cosine? Law of sine?
We learned about it in geometry. The law of cosine is the equation, like the a plus ab cosine of theta and then plus something. I don't really remember the equation anymore. And law of sine is like what we did last class.
Yeah. So you were not in the last class, you missed the last class, correct? Okay. So what I'll do is we'll do a quick recap of what is law of sine, what is law of cosine, how do we believe that those laws are correct, right? It should not be a sign, a rule or a law or concept imposed by the teacher. Let's decode it. And then we'll apply that for doing some problems. Arush, is that okay for you also? Yeah. So first thing first, our journey with trigonometry started with a right angle triangle, right? A right angle triangle, then you apply SOHCAHTOA, no sine, what is cosine and all that, correct? So when we start trigonometry, we go with the assumption that, okay, everything revolves around right angle triangle. That is not the case because we went from SOHCAHTOA to unit circle. And where we saw, okay, we can go beyond 90-degree angle in a triangle and then we can use the unit circle concepts to find out sine, cosine and tangent for angles more than 90 degree, even more than 180 degree. No triangle in the world exists which has sum of angles more than 180 degree, right? But we can still find out the value of sine, cos and tan for values more than 180, 500, 700, whatever you want to, right? That's what unit circle helped us with. Now we are extending further and say, okay, can we apply the SOHCAHTOA concepts or sine, cosine and tangent for any triangle? And that is where law of sine comes into play. Let's pick up a triangle which doesn't look like a right angle triangle by any means. Yeah? This is not a right angle triangle, probably an obtuse angle triangle. Maybe this angle is, maybe I'm not drawing it rightly, but this angle, let's say, assume that this is 120 degree. So this is not right angle triangle, that's what I'm trying to convince you guys for, okay? So, in this triangle, can I use sine, cosine and tangent concepts to relate to? And that's where law of sine says, let's say this angle is alpha, this angle is beta and this angle is gamma. So law of, and the side opposite to alpha is A, side opposite to beta is B, and side opposite to gamma is C. So law of sine says sine of alpha divided by the side opposite to that is equal to sine of beta divided by side opposite to that is B, is equal to sine of third angle gamma divided by the side opposite to that, C. You guys can see the full board, right? My finger visible here? Yeah, okay. Yeah. Because when I'm seeing my screen, I'm seeing only part of it. That's why I'm just checking. So this is what law of sine says. Okay? If you have any triangle, regardless of the type of the triangle, this holds true. This is what is law of sine. Now, first thing we have to convince ourselves, how does it actually help? What is the extra benefit or the knowledge that we are acquiring by this, which would be of any use? Can somebody tell me? Why we have to stress ourselves out to learn something new when we already know SOHCAHTOA, we already know unit circle? How is this guy helping?
SOHCAHTOA can only help with right angle triangles, and unit circle, it's like you cannot use it for this one because it's like, first of all, it's too much work, and I don't think we can get the sides out of it that bad.
Okay, let me give you guys one more weapon. Let's say I'm telling you that we have Pythagorean theorem also. So we have three things with us: SOHCAHTOA, unit circle, and Pythagorean theorem. But why do we need to go to this guy? So you're thinking in the right direction, beta. First argument that you gave was that SOHCAHTOA only applies for right angle triangle, so I cannot go beyond 90 degree. That is understood. Okay, Arush, any point of view? I want you guys to argue with me.
I was thinking that the idea that I could use on any triangle, just like.
Okay, so let's not go by the words. Let's go by some pictures, because pictures speak 1,000 words. Okay, so when we're talking about unit circle, we know the radius and we know the angle. But this tells us a relationship between one angle and some sides. This guy tells us about the angle and some sides. But if you look at a situation, let's look at this equation. Let's be assured that, okay, fine, SOHCAHTOA tells us only up to 90 degree. Unit circle gives us relationship for sine, cos and tan, x and y. So we know the angle and some of the sides we can figure out. Now let's look at this situation. What's happening here? I mean, so far I'm just forcing you guys to believe that this is correct, okay? Here, what's happening is, first of all, this is not a right angle triangle. Let's look at up to this part. Here what's happening is, if you know two of the sides and one angle, meaning I know this side and this side's length, and I know, let's say, this angle, alpha, I can find out the second angle, regardless of the triangle size. If I know two of the angles, let's say we know alpha and beta, and we know one of the side, we can find out the third side, we can find out the third angle, we can find out the third side also using this rule. So this gives us little extra ability to find out the relationship between the sides and angles and decode it. Okay? Now let me put one more situation. Again, this is not right angle triangle, okay? I know this angle, let's say this is theta. I know this side A and this side B. And if somebody says, find out all the sides and all the angles, what would come to your mind? How we can find that out? Can we apply this guy? This guy says, if I know angle and the opposite side combination, we can find out the other one. So here I have two sides, but not any of the angles opposite to that. Okay? Then I'm not able to leverage this one. So that is when the law of cosine comes into picture. It says that if you have two sides and the angle between them, you can find out the third side, C. It will be equal to C square will be equal to A square plus B square minus 2AB cos theta. Meaning the third side that is not known, square of that will be equal to square of this side plus square of this side and minus 2 times this side and this side times cos of theta. So this is your law of cosine. Okay. So Arush, I think I explained you the law of sine in the last class, and I was fumbling when I was trying to prove that law of cosine. So we'll do both of them together, and then we'll look at some problems. Okay. So Nancy must be thinking that what happened in the last class when the teacher was fumbling. I was trying to find out an easier way to prove this theorem, and probably I took a little longer, and then I thought, okay, let me not take that longer route and everybody gets confused. So that's why we kept it for proving in today's class. Okay. Now let's look at how legitimate and trustworthy are these two signs, and then we'll start applying them. But one thing that we have to kind of convince ourselves for, that law of sine works best when I know two of the angles and one of the sides opposite to those angles. Law of cosine works better if you know two sides and the angle between them. Then you can use that for finding the third side. Okay. Now let's look at law of sine, which says, and you guys can see the board okay, right? And if anything is not legible, let me know. I can increase the font. Law of sine says sine of alpha by A equal to sine of beta by B equal to sine of gamma by C, where A, alpha, beta and gamma are three angles of the triangle, any triangle, and A, B, C are the sides opposite to these angles respectively. Yeah. Now let's look at this triangle. And I'm trying my best to make sure that this doesn't look like a right angle triangle. Okay. So this is alpha, this is beta. Let me say alpha. Let me change the names a little bit. This is alpha, this is beta, and this is gamma. Okay. And the side opposite to this is A, side opposite to this is B. Oops, my bad. So here, there's one thing that I would want you guys to get used to it, is as we start getting deeper into these concepts, we always relate the angles and the sides opposite to that, okay? I mean, to visualize things, okay? I would not put this as A, this is opposite to the third angle. So that's why I'm just trying to make sure that I don't confuse you guys. This is my alpha, side opposite to that is this one, A. This is my beta, side opposite to that is B. This is gamma, side opposite to that is C. Is that okay? So if I mess up the sequence of these sides, this whole thing will go for a toss. Yeah. Now let's look at this one. So this is not a right angle. This is not a right angle triangle. This is probably an obtuse angle. Let's drop a perpendicular from here to here. This triangle was, let's say, PQR. We dropped a perpendicular from here to the opposite side, and this is S. Okay. So this is B, this is A, this is alpha, this is beta. Okay. Now let's pick up this triangle. This is one right angle triangle that we have drawn by dropping a perpendicular from here to here. Yeah? In this triangle PQS, triangle PQS, and just to make it a little more visible to you guys, let me shade it a little bit. So the blue one is the PQS. Yeah? And I see Nancy is struggling to see the board. So that's why I'm using some color coding to make it a little more visible to you guys. Okay? Then we have a red one. So this is the blue one, PQS. Okay? Yeah? And this is the red one. Triangle PRS. That is the red one. Okay? So far? Okay? So we have triangle PQS. This is the blue one. This is the triangle PRS. This is the red one. And both the triangles are a child of the larger triangle by dropping a perpendicular from here to the opposite side. Okay? Now, look at this PQS. So this is my angle alpha, and this is the side opposite to that. Let's look at what will be the sine of alpha. Sine of alpha will be from this triangle PQS, the right angle triangle, applying SOHCAHTOA will be the side opposite to that, which is PS, P2S, this length, divided by hypotenuse, which is B. Okay? Or from this we can say PS equals B times sine of alpha. Is that okay? Let's go to the red one. In this triangle, this is my angle beta. I'm looking at this only this baby triangle, okay? PRS, the red one. Here, what will be sine of beta? Sine of beta will be equal to side opposite this, which is PS, divided by the hypotenuse, which is A. Yeah? That means PS will be equal to A times sine of beta. Is that okay? Everybody okay? Comfortable? Okay. So, from this triangle, the blue one we found PS equals B of sine alpha, and from this red triangle we found PS equals A of sine of beta. That means I have a little bit of courage now to say B of sine alpha equals A of sine beta equal to PS. Is that okay? Why do we need PS? Forget about it. Okay? At least this is okay? So B of sine alpha equal to A of sine beta. Let's move B and A to the opposite sides using butterfly. Yeah? So B comes this side, becomes a denominator. A comes this side, becomes a denominator. So sine alpha by A equal to sine beta by B. Yeah? So sine alpha, we are moving A to this side, that becomes a denominator here, will be equal to sine of beta, and we are moving this B from this side, okay? B doesn't belong with alpha, okay? So I'm just moving it on the side. So we saw that sine of alpha by A equals sine of beta by B. Arush, Vedansi, both okay? We did not do anything fancy, okay? What we did was, we just picked up a triangle, which doesn't look like a right angle triangle, and from, we picked one of the vertices, and from there we got the perpendicular on the other side, and we split this into two right angle triangles. From this right angle triangle, we found out what is the sine of alpha. From this triangle, we found out what is sine of beta, and we found that this gives me, this triangle gives me PS equals B of sine alpha, this triangle gives me PS equal to A sine beta. So we compare these two, I mean PS is equal to PS obviously, right? So these two are equal, that means sine of alpha by A equal to sine of beta by B. And we just picked up two angles and we proved this one. You can flip this triangle, okay, and prove the, I will not flip the triangle, I will just, next time when I try to prove, I will rotate the angles, okay. I will call this as a gamma, this as a alpha, this is a beta. Side opposite to gamma will be C, side opposite to A, alpha, alpha will be A, side opposite to this one will be B. And we can prove the same thing basically. I'm just rotating the angle so that we saw, sorry. We saw that one combination of angles, this is proved, we can change the names and we can still prove it. So this rule is little more trustworthy than what it was before. I hope that statement is fair. Vedansi, Arush, both. Sorry. Now, so what this theorem says now is, if we ever come across a situation that we have two of the sides of a triangle known to us, and one of the angle opposite to either of the side is known to us, we can find out the other side, other angle, and other side also. Yeah. So if, let's say if you know, I messed up the picture, let me just, before I move on to the law of cosine, let's just digest this formula for ourselves and then we will see what kind of situation we can deal with knowing this law of sine. Okay. So let's say if I have a situation like this, if I have a triangle like this, and this angle alpha and this angle beta is known, we can find out the third angle, right? If we know two angles, we can find the third angle. So if we have these two sides known to us, and let's say this side is known to us, we can apply this rule to find out the side opposite to the second angle. We'll be able to find that. And then, since we know the two angles, we can find out the third angle, and from that, we can apply the same formula and find the third side also. So now we have come to a point, if we know two of the angles of a triangle and one of the sides opposite to either of the angles, we can find everything else about the triangle without any problem. Is that a fair statement? Wonderful. Let's move on. But if we know two sides, A and B, and the angle between them, can we find out all the three things? All the other properties? No, because we know two sides, but the angle opposite to this side is this one, which we don't know right now. Angle opposite to this side is this one, which we don't know right now. What we know is the angle here. There is no way we can determine either of the two angles from whatever we know so far. That is where the law of cosine comes to our rescue and says that if you have these two sides known and this side we are trying to find out, it says the third side, square of the third side is equal to square of the known first side and square of the second known side minus 2 times AB into cos of the theta between the two sides. And let's prove that. So far the pace is okay for both of you. If I'm not being very clear, you can attribute that to me having woken up just an hour ago. Okay? But you can hear me okay? Follow me okay? Everybody? Okay. Now let's pick another triangle which is again not right angle triangle. Okay? This side A and this side B is known to us. This angle theta is also known to us. Okay? Let's give it a name. P, Q, R. This is my triangle. Okay? Let's drop a perpendicular from here to here. This is point S. Okay? Now, from this triangle PQS, this one, we have the cos of theta, okay? We have the theta actually, okay? And we know this side. So, what is the length of this, what will be the cos of theta? Since we are saying it's law of cosine, so let's find out what is cos of theta here. That will be what? This length Q and S. Yeah, Q and S divided by hypotenuse, adjacent side by hypotenuse, QS by hypotenuse A. So that means we got QS, this length equals A times cos theta. Is that okay so far? Look at the sequence of events. We picked up a triangle. This is the theta known to us. This is the side A known to us. This whole side B is known to us. So what we did was, just to make it simple for us, we dropped the perpendicular so that we have a right angle triangle and we can apply Sukatua. And from that we took this small triangle now, which is a right angle triangle. What is the value of cos of theta? Cos of theta is nothing but the adjacent side by hypotenuse. Adjacent side is QS, which is, we know that it is a part of the side B, but it's QS. We don't know how much it is, right? So QS divided by hypotenuse, which is A. So that means QS, this length is equal to A times cos of theta. A goes this side, A cos of theta. So far okay? Now let's come to this triangle. Okay, before we come to this triangle, let's look at this one. We know cos of theta equal to adjacent side by the hypotenuse. What will be the value of sine theta here? Sine theta will be the side opposite to the angle, that is PS, divided by hypotenuse, that is A, Yeah? This length by hypotenuse. That means PS equals A times sine theta. Is that okay? And trust me, I'm not trying to act smart here, okay? I'm just telling you guys that we know this angle theta. We have a triangle. Since we are trying to prove the law of cosine, we just figured out what is the cos of theta based on whatever information we have. And then, if we know the cos of theta, we just say, okay, fine, let's see what will be the value of sine theta. And we found sine of theta is the side opposite to that divided by hypotenuse. So we found sine and cos theta. Okay. Now let's go to the other side of the triangle. This right angle triangle, PSR. Okay. Interestingly, we don't know about any of the angles here, except the fact that this is right angle. That's it. But we all have one uncle. We have one uncle since our childhood days, and his name is Pythagoras. Okay. So Pythagoras' uncle has told that if you have a right angle triangle, the square of this side and the square of this side will be equal to the square of this side. Yeah? The square of the sides making 90 degree. Sum of the squares of the sides making 90 degree will be equal to the hypotenuse square. That part we know. And this is C, which we are trying to find out. Correct? So, based on Pythagoras theorem, it says PS square plus SR square, S to R, this square will be equal to C square. Yeah? Or C square equal to PS square plus SR square. I just flip the side. Okay, that's all. Yeah? Now what is PS square? What is PS? From this we found PS equal to A sine theta. Yeah? PS, this one is A sine theta. We found this here, right? So this PS equal to A sine theta. So PS square will be equal to A square sine square theta. Yeah? So C square equal to A square sine square theta plus SR square. This guy has no identity, okay? This guy has no identity. But we know this length is nothing but this whole length minus this length. Correct? So SR square, whatever is the SR, square of that. Now this SR is this whole thing, which is B, minus this part, that will be by this length. So this part is QS, and we found QS equal to A cos theta. I know I'm kind of getting you guys a little worried right now. We'll look at the whole journey, and that will make it easy. Okay? So PS equal to A sine theta. I'm just PS equal to A sine theta. I'm just creating some real estate here. Okay? So let's go from the beginning. Okay? We pick the triangle where we know this side is A and this side is B, and the angle between them is theta, and we are trying to find out this side. Okay? And cos of law of cosine has given us that promise that you can find out this using this one, but we don't believe this one so far. So we took this triangle. Okay, we dropped a perpendicular from here to here. This became a right angle triangle, and this became a right angle triangle too. But from this right angle triangle, we say, okay, fine. What is the cos of theta? Cos of theta is adjacent side by hypotenuse, which is QS by hypotenuse, which is A. QS is part of the whole B, but we'll fill it out. So this length we found is this length by hypotenuse, which is QS by A equal to cos of theta. So QS equals A cos theta. Then in the same triangle, we said, okay, what will be the sine of theta? Since we know the angle, sine of theta will be side opposite to this PS divided by hypotenuse. So PS by A equal to sine of theta. So PS equals A sine theta. That's what we saw here. So we know this length and we know this length with respect to the angle theta. That's it. Yeah. We collected this information, then we went to this right angle triangle. So fine. This triangle we don't know much. We just know this side is C that we are trying to find out. This side which is part of B, and we have found out this length. So we just say, okay, fine. Since we know only about the sides and the relationship right now, let's apply Pythagorean theorem, which says this square plus this square equal to this square, or this square equals to this square plus this square. Now this square is PS. PS we found out a sine theta. PS square is a square sine square theta. This side is part of this side. So this side minus this side equal to this side. So this side is B and this part is QS, which we found as cos theta. So this became this SR square. SR square is this minus this whole square. So this is a square sine square theta plus a minus b whole square. So this will be a square, that is b square, minus 2 times b into a cos theta plus square of this, which is a square cos square theta. Yeah? We are talking about algebraic identity a minus b whole square, a square minus 2ab plus b square. B minus a cos theta whole square is b square minus 2ab cos theta plus square of this. Vidansi and Arush trying to process this one. Okay? So here's the thing. So let's assume that we from this one whatever value we have got, let me put it here. This QS is equal to a of cos theta. This part, okay? I'm just writing it here so that we have some space here, okay? Yeah? And we found PS, this whole thing is a sine theta. I've just written the finding from these two here, okay? So that we can create some space here. Yeah? I will go as slow as possible, okay? And stop me or keep stopping me until you are convinced. Okay? So this side here to here is B. Whatever I said, only keep these two things with you, which we have found from this triangle. Okay? Which I have written down. Now we are coming to this triangle, this right angle triangle, and we don't know about any of the angles. Okay? Here, in this triangle, this side and this side are making the right angle here. And this is my hypotenuse. Yeah? Pythagorean theorem says c square equal to this square plus this square. That means ps square plus sr square. Is there any doubt so far? No? Do we know the value of ps? ps here, a sine theta. So ps square I am putting as a sine theta square. Yep, this is ps square. Now sr square. sr, what is the value of sr? Square of that. What is sr? This length is nothing but this whole length qr minus qs. Yeah? So a sine theta square, that becomes a square sine square theta. Okay? Now going to this one. qr minus qs. What is qr? qr is side b known to us. Okay? Minus qs. What is qs? qs we have found out from this triangle. qs is nothing but a of cos theta. Yep. Don't be forced to be convinced, okay? So far, okay? Now, are you with me? I can see Vedansi looking convinced so far. Are you okay? Yeah. Now, come to this guy. If you guys remember the algebraic identities, a plus b whole square equal to a square plus 2ab plus b square. a minus b whole square equals a square minus 2ab plus b square, and a square minus b square equals a plus b times a minus b. Yeah, this part is okay. Algebraic identity, a plus b whole square, a minus b whole square, a square minus b square, these formulas that we have learned. So here we have a situation something minus something whole square. Something minus something whole square. Something minus something whole square equals something square minus 2 times this something plus b square. Yeah. So I have a minus b whole square. I mean, though it's named as a and b, but let me change this formula. Let me change this formula so that I don't get you guys confused. Let me say x minus y whole square is equal to x square minus 2xy plus y square. Is this okay? This is my x, this is my y. X minus y whole square. So let's break it down. So this part remains as is, a square sine square theta, plus this is my x, this is my y. A cos theta is my y, b is my x. So this will be x square, that will be b square, minus 2xy. So 2 into b, and this is my y, a cos theta, plus y square, which is a square cos square theta. Vedansi looks a little more convinced now. How about Arush? Yeah? Sure? Same thing, in this triangle we said, okay, we will apply Pythagorean theorem, this square plus this square equal to this square. This is PS, PS is nothing but we found is equal to a sine theta. So that is a square sine square theta. This SR is part of this whole side, which is b minus this side. So b is, this side is b minus this side. This side, this much is QS, which is a cos theta. So a cos theta is subtracted from b. So b minus a cos theta. And we are relating that with the algebraic identity, which says a minus b whole or x minus y whole square is x square minus 2xy plus y square. What is my x? My x is b. So x square. And what is my y? A cos theta here. Relating to this equation. So a square minus x square, which is b square, minus 2x, this is my y, plus y square. Yeah? Now, let's see what we can do. We have a square sine square theta and a square cos square theta. We can put them together. It becomes a square into sine square theta plus cos square theta. We brought these two guys together, okay? Because we had a square common in them. Plus this b square is isolated, it doesn't have a friend. It remains b square. And then minus 2ba cos theta, we can write this as 2ab cos theta also, right? A into b or b into a is the same thing. Now, a square into sine square theta plus cos square theta. Sine square theta plus cos square theta is 1. So this became a square into 1, which is a square, plus b square minus 2ab cos theta. That's exactly what this law of cosine was saying. I know it's a little stressful, but beauty lies in simplicity. We'll break it down. That's what we did. We picked a triangle, dropped a perpendicular. From this we found out what is the length of, what is the cos of theta, and from that we found QS, this length equal to a cos theta. And we found this one also because we had no clue about this side, right? This was just a perpendicular. So we found that out. If we would have not found this out in the beginning, this length, we would have struggled with this triangle, okay? This side is something that we are trying to figure out, but we know that this is C. Whatever is the value of C, we will figure it out later. This was known. And for here in this triangle to apply Pythagorean theorem, we have to find out this side. So that's why we found this side's length in advance. So that when we came to this triangle, we knew this side as this And this side is anyways a part of this whole thing. This whole thing minus this. This thing we had figured out. So we subtracted that, applied that algebraic identity, and we could believe that this is okay. And I mean, this is my opinion, I might be wrong, that you guys are probably 90% convinced so far. Remaining 10%, do the scratch work. Like I say, my hands get dirty when I teach you guys. I want you guys to get your hands dirty after the class, okay? Meaning just try proving it, okay, by yourself. Because me pretending to be intelligent or dumb is of no use for you guys. Whatever we are discussing in the class, just try practicing. It will not take more than 10 minutes, okay? Do it in your own way, following the steps. And if you get the same thing, you'll be 10 times happier than how happy you are right now. Okay? I'll let you guys do that adventure by yourself, for yourself. Okay? Now, let's move on. So now, we have seen law of sine, law of cosine. And at least you guys are sure that these are to be believed, and you also know that you can try it yourself to be doubly sure about this thing, okay? And again, why I keep asking you guys to get your hands dirty is because you will learn everything in the class, but there's a high likelihood that you will probably forget it. So if you want to make it part of your muscle memory, just try it once, okay? That will really be fun. If you guys see me being super excited teaching you guys, that is because I have that special affinity for the subject, okay? I want you guys to build that affinity as well, so that you start enjoying it. I'm sorry, beta?
Is there also law of 10? Like
No law of 10 that we are aware of. Again, we can learn it. We can learn it or we can derive it, okay? Now let's look at it. That's why in the beginning itself I was saying that why do we need to learn about these things? Okay? That was the first argument we started with. Okay? There could be a law of 10, we can derive it. I have not seen it. I will check the syllabus one more time to see if there's one. But then the goal is, what is the purpose it solves? We are not trying to overwhelm ourselves with hundreds of laws. We are more interested in figuring out what actually helps us with what intent. Correct? So that's why. Now let's look at our situation and conform or align to different circumstances. Let's say I know this angle and this angle. This is alpha, this is beta. And this is, let's say, B. B is known, and this one are unknown. And let's look at this triangle where we know this angle theta, this one and this one are known, and this is unknown. So what we are trying to do is, when you look at this situation versus this situation, you have in an exam-like scenario, when you have to make a judgment, you are equipped with law of sine, law of cosine both. You are equipped with unit circle, you are equipped with SOHCAHTOA. In this situation, you know that this is not a right angle triangle. SOHCAHTOA doesn't help. Okay? Then you know one of the side and two of the angles. And this side that you know is opposite to one of the known angles. No doubt about it. You'll not even think twice. Law of sine. Look at this situation. You know two of the sides and none of the angles opposite to this side. This is angle opposite to this one. This is the angle opposite to this one. None of the angles are for the known sides are known to you. Law of cosine without any second thought. Okay? Let's pick one problem. I want you guys to deal with one problem, make your judgment, and then be sure that, okay, whatever we have learned, we applied that to one of the concepts. Applied that concept to for solving one of the problems. Let's look at it. So, where is the problem? Many times what happens is, I get super excited to teach you guys, and then I myself don't bother to look at if there's don't bother to practice how to solve the problem. I mostly don't practice, I just look at the problems because I have practiced when I was your age. So I assume that I should be able to solve it. Sometimes I kind of end up struggling. That is why many times I take the longer route. But we'll see. Let me not get you guys distracted. We have a question here. It says this point is given as yash. I don't know what yash means. This angle is not known, a question mark. This side is given as 30 meters. This side is given as 25 meters. This angle is given as 41 degrees. And this side says Dennis. And this side says Vera. Let me read the question for you guys, okay? So I see a picture of a triangle. This angle is given to us as 41 degrees. So these three coordinates are given name, Yash, Veera and Dennis. Maybe these are three friends at the three vertices of a triangle. And this side is given 30 meters, this side is given 25 meters. This angle is not known to us. Now let me read the question. It says, what is the minimum camera view angle Yash can use to see both Dennis and Veera? So Yash is at this point, he is having a camera and these two friends are sitting, he is 30 meters away from him. Veera is 30 meters away from him. He is trying to fix up a length of the camera so that he can see this friend and this friend both, who are themselves 25 meters away. So I looked at the picture, read the question, and I'm trying to make a story out of it. So the question, I'm just reading the question one last time, says, what's the minimum camera view angle Yash can use to see both Dennis and Veera? This is 30 meters, this is 25 meters, this one we don't know. This is 41 degrees, we don't know this one. Now the question to you guys is, how would you approach this problem? Solving would be easy. How would you approach this? Which law you would use here? Law of sine, law of cosine.
Law of cosine. Because you only know one angle.
You only know one angle, but what does law of cosine need from us? Law of cosine needs two sides and the angle between them. If you know this side and the angle between them, then you can use law of cosine. Yeah? So here, you know the two sides, but we don't know the angle between them. This side is not known yet. Law of sine says angle and the side opposite to that. Second angle sine and the side opposite to that. Here if you look at this side, see this side and this side are known. So you can deal with the angles opposite to that. So this side's opposite angle is this one. This side's opposite angle is this one. Oh, this is what you have to find out. So let's say this is x. Are you with me? So this is the angle that we are trying to find out. Side opposite to this angle is known to us. Other side that is known to us, this angle opposite to that is known. So the catch here is, if any of the side and the angle opposite to that is known, you are better equipped for using the law of sine. If the two sides and none of the sides have angle opposite to them known to you, only the angle between them, then you are better off using law of cosine. Yeah? When you have two sides and the angles opposite to both the sides are not known to you, then you are better off using law of cosine. If you have any of the side and angle combination known to you, then you are better off going for law of sine. So here in this case, you are better off using law of sine. So this angle is not known. Let's say this is x. So sine of x divided by the side opposite to that, which is 25 meters, is equal to, let's look at the other pair where we have angle and sine both known. Sine of 41 degree divided by this side, which is 30 meters. So sine of x equals 25 meters by 30 meters times sine of 41 degrees. Yeah? So you can find out this angle. This is the minimum camera view angle that Yash would need to be able to see both the friends. Solving, see again, you guys will have calculator for finding it out, okay? I don't have a calculator with me right now. I can make some judgments here. What we know is sine of 30 degree is equal to half. Sine of 45 degree is equal to 1 by root 2. 1 by 1.414. This is probably 0.7 something. Okay. So sine 30 is half, 0.5. Sine 45 is 0.7. I will do some interpolation, okay, to say probably sine 41 will be little less than sine 45, maybe 0.61 or 62. I'm just making a guess. You guys will have calculated to find out what is the value of sine 41 and you can plug it here and you can derive it, okay? Okay, so here 30 to 45 is 15 and for that, for 15, I'm going from 0.5 to 0.7. So 15 is given 20, so 1.1, 0.4, yeah. So I'm coming by 0.4 down, 0.6. So this will be like 0.64 or 0.63. I mean, just roughly. Okay. You guys can use your calculator in each way. From that, you will be able to find this angle. How much this value would be? That is not something that is bothering me right now. What I would want to be concerned about is which law of sine to use. That is where, Vedansi, I'm not sure if you have heard this enough from me, but I will keep telling this to you also, like I have tortured Arus enough. This is my concept. Okay? Read, analyze, and then Nike. Nike says just do it. I have not told this to you, is it? Oh, Arus, have fun. So this is the concept that I practice for myself and I prescribe this to all my kids, okay? The story behind is, if you are running a race, who wins the medal depends on who ran the best, okay? But we are not talking about track and field event. We are talking about applying the RAN concept for solving problems. I always say, you have a problem to solve, read the problem once, twice, thrice. When you read the problem, you extract all the information from it, then you are clear what this question is asking for. Then you start analyzing it. Okay, this question is asking for this. Oh, these are the options I have. This is when you will decide between law of sine and law of cosine. You are analyzing, you are making a blueprint, you are making a plan. Okay, you have not touched or you have not attempted to solve the problem. You are still making a plan, strategy. And then you go to end. And stands for Nike. What does Nike say? Just do it. So what I prescribe is, when you have a question to solve, what happens is, as a normal human being, we get tempted to start solving it. I say, no, take a step back. Read the question enough so that you don't miss on any of the important information. Put your plan, make your plan, and then you jump onto solving it. You are here in an exam-like scenario. If let's say in this case, you have two options, law of sine, law of cosine. You started with law of cosine. You found out A and B. And then you realize, I don't know the theta. Gone. Whatever time you spent, 2 minutes for solving it, and then realizing, this was not the right approach, I had to go for law of sine, those 2 minutes that you spent, that is lost. When you do this analysis, You will take 30 seconds to make your judgment. So those 2 minutes, wastage of those 2 minutes or 3 minutes that you would have done otherwise, that you are minimizing. And every second, every minute that you save in an exam is worth at least few grands, if not $1 million. Yep. That's why I prescribe this. I know Arush has heard this enough from me. Sometimes kids get tired of me, but in a way, I'm emphasizing the fact that whenever you are dealing with any problem, be it in an exam, be it in a real life, think about it and then try solving it. Otherwise, you might take a wrong route, and both will not give you the desired result in the time that you have at hand. All right, was that a great speech? No, I'm just kidding. All right, have fun, kids. We'll meet again. Once I upload the video of the class, watch it once, then try solving few problems, and then if you get stuck, catch hold of me here. Okay? All right. Take care. Bye-bye. Bye-bye. Bye-bye.